Hey friends, we're now continuing in chapter 4, but we actually are combining two sections, 4.3 and 4.6. We're continuing proving triangles congruent, and yesterday we started with the fact, and I emphasized the fact that you had to show three things before you can show triangles congruent. And we started with which two? We started with the side congruence and with the side congruence. And the letters tell us exactly what we need. We had the side, so we needed 3 pairs of corresponding sides. We had side congruence, which means we had 2 pairs of congruent corresponding sides and 1 pair of congruent angles. And the angle had to be included between the 2 sides, so it actually had to be like an hinge effect. So we would actually mark them on the diagram to decide if we had the triangles congruent. And if we didn't have those, it didn't work as well. And then we actually started about with a vocab word that was talking about including angles, but we also have included side, and that is the common. And I think yesterday I called it the shared side of 2 consecutive angles. Make sure I move that over a little bit. In a polygon. Now, the cool thing is, that's very easy to understand because we talked about it yesterday. We know segment PQ is the included side of angle P and Q because it's between those 2 angles. It's what's shared inside. Segment QR would be between angle R and angle Q. Segment PR would be between angle P and angle R. So we're actually going to use that to solve for more congruencies also. Now, we're going to quickly, I'm going to go through the next 3 theorems that are going to be working with. And the first one is called the angle-side angle congruence, and we will abbreviate it ASA with the congruent symbol once again. It states the following. If 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the triangles are congruent. So basically it's angle, side, angle. And the reason why this works is because the angles would actually, because of always being the same, kind of direct what the second and third pair of sides would have to go. They'd always have to intersect at the same spot. And so just like before, I always label on the diagram the info that I have. And if I can read angle, side, angle right consecutively, I know those are the ones that we have. Now, the next one is actually called the angle side congruence. And the reason why this works is actually using angle, side, angle. Now here's what I mean by that. Remember before we had a theorem that said the following. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. So we'd have our 3 marks here. Well, that means then, 1, 2, 3. That means we'd actually have angle, side, angle. What angle, side does is actually saves us time. So with this one, we're going to be angle, side. But here's the thing. Make sure your side is always opposite the same angle. Otherwise, it doesn't work as much. So let's write this one. If 2 angles and a non-included side of one triangle are congruent to the corresponding angles and non-included, should be a C there, side of another triangle, then the triangles are congruent. So we're going to be using angle, side. So notice I only marked those third pair angles just to show you how we would prove this theorem. So Also, we're going to make sure I remind you, this is how we're going to abbreviate it so we can work with it. We'll call it the angle-side congruence. All right, now just a quick review of working with right triangles. Remember, when we have a right triangle, we have a right angle. The two sides that make the right angle are called the legs, and then the longest side is always the hypotenuse. Now remember, the other day I just said we never ever use side-side angle unless it's a right triangle. Well, it's because of the Pythagorean theorem that we can do this, and so it kind of helps stipulate it. So what's the third piece of information? Because this only says right here HL congruent. The third piece of information is you always have to tell me that the triangles are right triangles, or this doesn't work. So on this one we go if the hypotenuse and a leg of a right, and I just abbreviate RT, right triangle, are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So basically you have to, the three pieces of info you need is it has to be right triangles, you have to have the hypotenuses that are congruent, and legs that are congruent. So notice, here's your hypotenuse, here's your leg. Hypotenuse, leg. So I have to have those. Those are the three pieces that work. So we always have to look for those right angles in order for this to happen.